All right, we're going to wrap things up here in Unit 7 with the putting basically everything together here. Okay, so we've got some guided practice of how we graph. The first one is in factored form. It's going to make certain things easier for us, certain things a little more difficult. Let's check out our leading coefficient here. When it's in factored form, we're literally just looking in front, okay, to see if that leading coefficient is positive or negative. A little typo here saying even or odd. We don't care if it's even or odd, we care if it's positive or negative. So the leading coefficient is positive. The degree here, let's see, 1, 2, 3 x's in factored form. If we were to multiply all this together, we would get an x to the third, leading to a degree 3, which is an odd number. That's going to be important. So our end behavior, if we check out our chart, positive and odd, our end behavior should look like this visually, okay? And then as x approaches infinity, that's to the right. Y will approach infinity because when it's going right, it's going up. As x approaches negative infinity, that's the left side of the graph. Over here, it's going down. So y will approach negative infinity or down. Okay, so we took care of our end behavior based on the leading coefficient and degree. Let's check out our x-intercepts here. Well, it's in factored form, so that makes this easy. We're going to plug in 0 for y. We'll do that up here in the top right. And we'll just use our zero product property to set this one equal to 0, this factor, and this factor equal to 0. We get -1, we get 1, we get 2. So our x-intercepts, -1, 0, 1, 0, and 2, 0. Awesome. Let's do our y-intercept here. We're going to plug in 0 for all these x's. 0 plus 1, 0 minus 1, 0 minus 2. Remember, that's how we will always find a y-intercept. Plug 0 in for x, solve for y. We get a 1, a -1, and a -2. Multiply all that together. We get a y-intercept of 2. So 0, 2. All right, here's what we're going to do. We're going to plot all these points on the graph, the x and the y-intercepts first. -1, 0 here in blue, matching up. 1, 0, 2, 0. We're going to go up to 2 to plot our y-intercept. This is what's happening in the middle of our graph. It's going to cross these x-intercepts, and then the end behavior should be right. So we're going to graph left to right with our end behavior. So we know we should be starting in the lower left, okay, because of our end behavior. So we're going to start down here at the bottom. We're going to come up, as we're going kind of left to right, up through that first x-intercept. And really when we're graphing this, it's going to turn and go back through each of these x-intercepts, and it's going to look kind of wave-like, okay? Making sure that we're going through the y-intercept wherever it lies between two of these x-intercepts. So here, we're going to start here, we're going to go up through that x-intercept. Now we know that the y-intercept is between these two, so the next thing I'm going to do is go to the y-intercept and go through that. Come back through our next x-intercept, come back through our final x-intercept, and really, guys, your end behavior and the amount of x-intercepts has to match up. If there was another x-intercept, let's say we did this wrong, we would have to go back down through it, and then our end behavior of down and down wouldn't match the end behavior that we figured out here, okay? So we're going to go through that. Makes a lot of sense that it's our final x-intercept because we know, based on our end behavior, that we should end going up as x approaches infinity. And we're good. I just saw the work for x-intercept and y-intercept spots. We can draw some arrows if we want to. That was our work for our x-intercept. Here was our work for our y-intercept. Let's go down to the next one, our final one. This is in standard form. Okay. That'll make certain things easier, certain things harder. So the first thing I'd like to do is take a look at the leading coefficient here. Again, we're not concerned even or odd. We're concerned positive or negative. The leading coefficient here, that is negative. The degree, since it's in standard form, we're just taking the highest exponent we see. The degree is 3. That is an odd number. Taking a look at our chart, negative and odd, our end behavior should look like this, which means as x approaches infinity, that's to the right, y is approaching negative infinity right here, it's going down. As x approaches negative infinity, that's to the left, y will approach infinity because it's going up on the left side of our graph. X-intercepts. All right, let's plug in our 0 for y, and we're going to solve for x. We're going to have to do some work here first. We're going to have to do some factoring. Let's take out our GCF. They each contain an x. We have all the numbers divisible by 2. Our leading coefficient is negative. That should lead us to a GCF of negative 2x. Let's continue to factor here by using our guess and check method, x and x, 3 and 2, positive, negative. That would work out for us. Hopefully you guys are feeling super comfortable with our factoring by now. We've done it for a few units already. Set each factor equal to 0. We're going to use the zero product property to solve for x. We'll get x equals 0 after dividing by negative 2, x equals negative 3, and x equals 2. Our y-intercept, we're going to plug in 0 for all the x's. This should make things really easy for us because each term has an x, which means that our x-intercept is just 0. Now you should have already known that. Okay. Sorry, I kind of lost our work here. We can re-go over our x-intercept. I was working off the screen there. We set our trinomial equal to 0. We factored, pulled out a GCF of negative 2x. Factored what was left. Set each factor equal to 0 separately. Solved for x. For y-intercept, I just plugged in our zeros for x. Solved for y. I got 0, 0, which makes sense. If we have an x-intercept at 0, 0, we should have a y-intercept there as well. Again, this would kind of be our x and our y-intercept. Kind of highlight that in green there. End behavior, if we start on the left, we're starting up here based on our end behavior. So we're going to start up high, come down through that first x-intercept, go back up. Again, should match up with our end behavior. This is our final x-intercept we're going to go through, which leads to a nice match of our end behavior. Some guided notes. The next page will have some individual practice for you guys to become an expert on our polynomial graphing.